All right, let's talk about new equipment. When you get a shiny new machine, you just expect it to work, right? But what if the biggest costs, the real costs, are completely hidden? Today, we're going to dig into how you can make sure that new machine is a total workhorse from day one, and not some money pit in disguise. We're talking about building reliability right from the ground up.
So I want to start with just one number, 80%.
And I know what you're thinking. 80% of what? It's a huge figure, and trust me, it represents something that most of us completely miss when we're looking at buying new gear.
Yep, that's the percentage of a machine's total maintenance cost that is already decided before you even swipe the credit card. I mean, just let that sink in for a second. 4 out of every $5 you're ever going to spend on keeping that thing running is decided way back in the design phase. It's kind of mind-blowing, and it's exactly why getting the very beginning right is so critical.
So, here's our game plan. We'll kick things off with the blueprint. Then, we'll uncover the true price tag. After that, it's time for the final check, and we'll wrap it all up with the post-launch plan.
Okay, first up, the blueprint. This is all about baking reliability in from the absolute get-go. You can think of it like the foundation for a skyscraper. If you mess this part up, the whole thing is going to be shaky.
Look, reliability isn't just luck. It's something you have to engineer on purpose. It all starts by taking best practices for maintenance and reliability and making them part of the design criteria. Then you have to intentionally design in the features that make it reliable and easy to maintain. And finally, you've got to analyze everything early on with tools like reliability-centered maintenance to really make these choices count.
So a solid blueprint is key, but what does that really mean for your wallet? Well, that brings us right to Section 2, the true price tag. We're going to dive into something called lifecycle cost, and this is where the worlds of engineering and finance really smash together.
So, what exactly is lifecycle cost, or LCC? It's simple, really. It is not just the sticker price. It's the total cost of owning that thing over its entire life, from the day you buy it to the day you haul it to the scrapyard. We're talking purchase, setup, running it, fixing it, everything.
And this chart, well, it tells the whole story, doesn't it? That initial purchase price feels like the biggest hurdle, but look at it. It's completely dwarfed by the long-term costs of maintenance and spare parts. Over the machine's lifetime, those operational costs are the real story. They are the lion's share of the total cost. And boom, here's where it all clicks. We're right back to that 80% number. Most of your maintenance costs are locked in tight during the design phase. This is the direct line connecting the blueprint to the price tag. The decisions made on a drawing board will be echoing in your budget for years and years to come.
You know, whether you call it a life cycle cost analysis or a total cost of ownership analysis, it doesn't really matter. The bottom line is exactly the same. If your financial plan doesn't seriously account for maintenance strategies and spare parts, you're basically flying blind.
Okay, so you've designed for reliability, you understand the true costs, but how do you actually know you got it right? Well, it's time for the final check. This is all about verifying that the equipment actually lives up to the standard you set for it. This is the prove it phase. You can't just hope the design is reliable. You've got to test it. Through acceptance tests and commissioning tests, you get the hard data. The goal here isn't just to see if the power light turns on. It's to prove, without a doubt, that all those reliability goals from the design phase have actually been met.
So the design is verified. The equipment is ready to roll. But hey, the job's not quite done. Our last section, the post-launch plan, is about looking ahead and figuring out what's really critical to its success.
Now, the order you do things in is super important here. First, you build in reliability during the design. Second, you prove that design works through testing. And only then, after the design is locked in, do you move on to assessing the criticality of the equipment. It's a totally separate and really vital final step.
So, what is an equipment criticality assessment? To put it simply, it's figuring out which parts of your new system are the most important, the ones that are absolutely vital to the whole operation. This helps you focus your maintenance, your spare parts, and all your attention on the stuff that just cannot fail.
And that kind of leaves us with one last big question. Your new equipment is built, it's verified, it's up and running. But do you actually know which single part of that entire system you cannot afford to have fail? Because believe me, answering that question is the key to keeping it running reliably for its entire life.